is Ingo Hild. I'm the plant manager of AMS Osram of the plant in Schwabmünchen. Schwabmünchen is located very close to Augsburg. If you expect that we produce in my plant a light bulb, I have to disappoint you because we only make pre-materials. Pre-material makes only a small piece of the final product, but is the most important part of it, because without my plant, nothing would be, illuminate anything. So I'm the most important part of Osram. So I believe everybody knows Osram, so we are responsible for the light. Might be that's some of my products or from the competitor, but nevertheless, I believe Osram is well known. But AMS Osram, I believe you have to struggle a little bit. So that is something I would say the agility comes up because normally the larger company bought the smaller one. But AMS, a smaller Austrian company, just bought Osram. So I think this is also coming up new, that if you are not fast enough, somebody will take you over. Osram has a very strong history, about 110 years, and that's also a burden because in my production area, I have a brownfield area, so not a greenfield. So I have to build up everything from ground, but I will show you in a few seconds. AMS Osram is known for visualization. We also illumination and sensing. I think it makes sense to combine all these topics together because in the past, light was always only turning on and turning off. But nowadays, light is much more. It gives you emotion. It also interacts with you. I think it's much more, and therefore to have a sensor, to have electronic, and to have light. Finally, this makes a bright opportunity to gives you much more functionality. In my plant, that is a plant built up 1961. So quite old. I have currently almost 300 employees. We produce metal, so tungsten and molybdenum. So yes, for sure, this is still needed in the lamp industry. So if you think about the light bulb, for sure, you are not buying a light bulb from the past. Today it's LED, but some of the metal products still get used in that area. We also produce phosphor. I will show you later what changed there. We come from a high mass production to a smaller production. And the latest technology is the LCP platelet, where we put in the phosphor in a ceramic. When you ask what is the functionality of a phosphor, it's very easy. It changes the light color. Normally the LED is a blue color, and nobody would like to have a blue light at home. So it transforms it from blue to white. So that's the functionality. So what's happened, and that's if we go on the journey, it's very important to understand where we are coming from and what's happened with I would say with the whole company. We are coming from the mass production. We had the opportunity to build up the light bulb over 100 years. So we can spend a lot of time to make the process more efficient. But nowadays, the product disappears and we have mainly only projects that we have to deal. And now you can imagine if we have to make a transformation from a mass production to a project, that's quite a big step. So when we heard from the presentation about human, so everything is related as well in that phase with human to change them from the mass production to the project. As well, if you are looking on have the quantity that we produced in the past, there are over 4,000 tons. And now for the LED, it's much smaller. We only have to produce 4 tons. So that's quite a big change in the volume, but still the complexity is very high. And also, and that's coming to the reason why we went for a digital twin and as well for the AI topic to optimize the quality in the production is, in the past, we produced products, and if the quality is not that perfect, to the light bulb industry. But finally, this disappeared. and the customer that remains, it's only automotive. And the requirements in the automotive is much higher. And therefore, there is only one way. We have to improve the whole production from 1961 to the highest level that we can imagine. And that is the reason for the whole digital transformation. And this is also something that helps me to tell the employees why we are doing this. So, and that's the picture that I like when I talk with the employees. I tell them always, we have to do the change. Yeah. This picture, I thought at the beginning it is self-explaining. I told them, we are the fish and we have to jump to the next, glass. But then I realized there is a mistake, because somebody told me, no, Mr. Hild, I would like to stay in the first glass. That's fine with me. Then I worked out, because I have to tell them that the products will disappear, and if we do not make any change, we will die. So with this reasonable explanation, I believe I get all the employees behind of my transformation process. But when we do the transformation, I would also go back. I saw it today, I believe from Porsche. They also had a slogan, lean, green, digital. And I think that's very simple. If you have processes in the production, you have to make them clean and eliminate the waste. And on the top, you go for digitalization. And nowadays, for sure, it's green. But we did it since many years, but now we just label it. So the digital transformation, and that's a strategy within the plant, because when we always see the, I would say, very easy explanation how to do it, I think it's quite difficult to make it on the production floor when you have a brownfield plant. So the first topic is we start with the mind change. It's very easy. It costs nothing except of time. And power to speak with the employees and to train them. The next step, if you have a plant from 1961, it's not difficult, to narrow the process deviation. You just kick out the old process controller and you buy a new one, because they are much better and they gives you the opportunity with additional feature. And then I believe that's the major topic, and this is something that I have to highlight and you show later. It's the traceability system. So if you go for data analytics, you need a one-to-one correlation of your products to the quality parameter and the process parameter. At the beginning, we never thought about that. We thought, okay, we collect a lot of data and it should be good enough, but finally we were not able, to come to the truth, and therefore this is the backbone. And when you collect all these data, you would like to go for data analytics, and this I will show you two examples what we do. That's the final stage. But if you say what's the fourth part, I'm electrical engineer, and since I'm working for Osram over more than 20 years, I got always the request after I did collecting some data, I need more data, I need the pressure, I need the temperature. So always the fourth pillar is to invest for additional sensors. So all in all, it's very important to bring the data together, but with the brownfield plant, I think it's quite difficult, because with the old controllers, they do not have any connections. You cannot get any data. Therefore, we just throw out all the old controllers and we installed the new PLCs with a connectivity. And now I'm coming to the backbone of the traceability. If you see on there the value stream within my plant, I have over 60 process steps. So that's quite, I would say, a complex process. And therefore, I have to handle that we take care that each piece is labeled. But I have a problem, because after certain steps, you are not able to read the label anymore, because I have to heat them up very high. You will see later a picture. So over this 60 process steps, I have to read and write 34 times, the label, and I have to take care that I label it after the process again. So it's quite high complex, and that you have a better understanding what I'm talking about. This is one rod in my production. So that's quite an early stage of a wire, yeah, that you know from the light bulb. And you can see here the rough surface, and you can see two labels. So it's a 2D barcode that we laser on that product. So it's quite difficult. At the beginning, we thought to label is very easy, but finally to make that robust, that you can read it all the time, that's quite difficult. So this took also, I would say, a long learning curve, but you should never stop to optimize it. Now it's running, I would say, quite perfect, and therefore each single product gets now all the data with the quality data and the process data. And what's happened, installed that system, the quantity of the data increased dramatically. So this is something I believe that's sure, but to see it in reality helps to understand what's happened behind. And today we heard from all of the guys who made a presentation that the data has to be collected, and that's also here. And to store this data is also at the beginning, I would say, not complex, but later on when you collect more and more, and it's also some topic. But the main improvement that we got over the last year is exactly that step. You have to understand, in my production, it's completely different to a car assembler. You know, when I start with my pre-material, finally I sell thousands of products. So it's not 1,000 pieces gives me one car. It is completely different. So the final stage is the single product that goes to my customer. And you see that we increased, you know, the accuracy by 10 times. So I know all the process steps in my production. I know when I started. I know where the product is laying. I know you know, how much I put into the process step. I know how much I get out. So I have a precise, you know, view about my production. And when you collect all these data, so that was the philosophy at the beginning. We thought always, okay, we use these data downwards to optimize the process. And finally, we also intend to use the data from the customers to optimize the process backwards. And that was the philosophy. And like I said at the beginning, we thought always we take, you know, a bunch of data, we hire some data analysts, and we get a result, and we solve all the problems we never solved before. But I had to learn that this does not work. So finally, we never found a big nugget. You know, we found always incremental improvement steps. How we did the whole structure, and that's a very technical overview. This overview shows you the structure over 3 plans. So at first we have the IoT, I would say, input level. That's on the lowest level. Therefore, the sensor specialist has to take care that the sensor is calibrated very well. Then we have to integrate the sensor in the PLC. So we have to take care about the programming that we have to include them. Afterwards, we have to install all the data in the database. And there you can see different database because they are stored locally. We do not shift it directly on into the cloud. So it's stored locally at first. Then afterwards, we transfer all this data into the cloud. That's the data engineer. And afterwards, we do a data cleaning. We take care that everything is correct. And then we have the data scientists. But what I learned is that we need the whole bunch of all these professions. So sensor specialist, PLC, the data engineer, and we also need the data analyst, and we need as well the process engineer. All of them have to work together. What we did, and that's an example in my plant, I have a sintering process. Sintering process means when we have the powder, at the beginning, we have to press, you know, a rod a bar, and then we put it into, I would say, a very high currency. So over 13,000 amperes goes over this bar and sinters this molybdenum or tungsten powder together. Afterwards, it's stable and you can treat it again. And the question was always this process. And therefore, we said, okay, we would like to take the data, we do deep learning, and we get a better process understanding, and we control it. So we are coming from lean. There we have the PDCA cycle, but it's not in the data analytics, the PDCI cycle. It's a CRISP cycle, so that you have always the question for your problem, that you feed in the system, that you go for data understanding, you prepare your data, you do the data analysis, and finally you get a result. So what we did is finally we feed in the system all the values that we have. Here it is our chemical input parameters. That was quite difficult to collect all the data that we have, because it's not, you know, like we have 1 million of them. So they're only for a lot, and that's quite less quantity. So we train the system. We feed it with the continuous production. And finally, we got an unknown high-dimensional function of, you know, the parameter. So we are interested in the density of the final product. And so with the input parameters, we can describe it. And now we have the functionality. That's very complex. For sure, this guy who did this in the background, he's very intelligent. But the question is, how to deal with it when you got this result, and how to handle it, and to get, you know, your return of invest. It is very easy. So when we have the process, we take the parameters from the production, we bring it to the shop floor, yeah, and there we discuss this problem. We feed in these parameters into this software. We discuss about this, we calculate, we get a result, and we take this result and bring it back to the sintering bottles. If you ask why we are doing it not automatically, for sure this is something that you can do later on. But when you start this process, you know, we are also on a learning curve. We do it manually. And with this, we have quite a good interaction with the employees. So we can also evaluate whether this calculation and the functionality is correct or not. So we learn during the time. And the next step for sure is when we have the result and we see that it's running, we can do it automatically. But there, currently, we do it by using it with the shop floor management. So the next one is the second example. There, the process in the wire drawing is, I would say, very easy. You have a wire, and on the very top left side, you can see the quality result. Always when you see a peak, that means that is an error. It is a crack inside. We're doing it with a measurement system. So what we try to avoid is such a crack. So if my production is running perfect, we would have very less amount of cracks inside, so less peaks. But after drawing, you get a longer wire. And the question is always, what is, you know, the change after one process step? Because I have one problem. I cannot throw the cracks away because the wire is a continuous production. So I have to take care that this continuous production is as good as possible. And now you are able to see the difference between the input material and the final product. Because it's longer, it's very difficult to compare. So in the past, some of the production guys took the pre-material chart and the final chart and looked over that. But that's, I would say, not professional. But to do this automatically, it's not very easy. So you cannot just stretch it. It's very complex. Therefore, we work together with the University of Munich to work on a dynamic time warping algorithm, and to, you know, to combine the pre-material with the final material to see what is the relative, additional crack that each machine is producing. And on the right side, you can see a type of a heat map. So you can see how this machine has an influence on the quality level. And now you can imagine you have not only one machine, I have for the process over 60 process steps. So I have to really get a good overview. So that's quite difficult. And so what we are doing behind of that, we are taking the pre-material, we're taking the output quality, compare it and see what's happened. And afterwards, like I said, we use the result in the shop floor management, to discuss it with the relevant process engineer to see how we can influence it. But on the other side, we are one step going forward. We already have some rules during the production when we see there is, something going wrong. Then we are also able to send a ticket. We would call it anomaly detection. So if something is not proper, then we get a ticket. And this ticket manager is getting directly linked to the people who are able to solve that problem. So if it's something electrical, mechanical, then the ticket goes directly to this person. So in total, at first, using the algorithm for the shop floor, a second to go with, I would say, some other algorithm. But if you are wondering why we are doing this algorithm by ourselves, we never found, currently somebody who provides immediately the algorithm that we need. So it's a specific area, and therefore I'm very glad to have the data scientific on my plant. And what I learned, like I said at the beginning, it is not the real solution that I got after one cycle. I learned that it's a continuous improvement step. After, I have one result, I have to go back and adjust the functionality again and again. And this helped me a lot. So the digital twin that we have over the process, we use all this data for sure for the, I would say, AI topic. We have machine learning, we have this special algorithm. We try to use it on autonomous reporting and to send tickets. But on the other side, I think it's also a value for us to have all this data in the background to use it in the daily shop floor. So we are not only using the result of this specific algorithm, we are also just using the simple continuous chart to have a look on it, how the process is running, is the process deviation increasing, is it okay? And the employees are very easy to access these data by using the Power BI. And how this shop floor looks like, this is just an example that we have in the production area. So we do it daily, the shop floor management. There you can see some manual charts. We also have some laptops and some monitors where the guy who is doing the shop floor is able to click on some chart that he likes to show. So this is accessible by Power BI. So we are using this software quite well, and I think it's quite. It helps us to go, forward each day. When we are looking for using the data, for sure we are looking for the quality improvements. Might be just comment about the quality level. It is not in the auto industry that we are going for percentage of quality level, not anymore for ppm. So like we heard it today, it's single incidents. So we take care about a single incident, and therefore the requirements are very, very high. And if we have one mistake, the business unit boss has to travel to the customer and have to explain why this happens. When we all have this data in the background, the question is how we can use it additionally. And I like today, you know, the Google topic, you know, to navigate through the production. So this is something that we are looking forward, because I have a production process that's quite complex, many machines, and to fill up and to feed up these machines, I would say that's quite scientific. I believe with all these technologies that is available, we are able to navigate in a shorter time, to reduce the cycle time, and this is something that I'm going forward. Therefore, we are doing a proof of concept with the company Collector to optimize the process flow in the production, to minimize the time, and finally to save money and to reduce the stock. But almost at the very end, I liked really, you know, to emphasize that the employees are very important, because I believe as well we have to start with the employees to go for the transformation, especially in digitalization. We see that it's going forward quite fast, even the last few months when we see ChatGPT and AI is coming up more and more. I believe that we are losing many of employees, especially when they, you know, were in the school, might be 30 or 40 years ago. So that's quite difficult. So we always have to remember that we have to train them. And we have to keep in mind that they do not know what's Apache. They do not know what's Python, R. We have to explain them. Can you imagine you tell them, yeah, we program in Python. So at first we have to tell them in German for sure, because we are a German company. But nevertheless, it's not a snake, you know, it's a program language. So I believe that he struggles not with an old program language or with a modern, he has to struggle to understand it in total. And therefore, my program is always start with the employees, train them, train them much more than you believe that it's necessary, because we do not know what will come in future and how we have to combine this knowledge. And therefore, I invest a lot in the employees. And currently, I think when I see the technology, it is not the technology that's coming up. It's the speed that we have to combine this technology to get the value out of that. And therefore, we have to train them in advance, that we are prepared for the future. And I also like today that somebody already mentioned that we have to do some mistakes. This picture, I think represents exactly that we have to do as well mistakes if we go forward. If we have to be fast, that's like in a soccer game or in another game, you will fall down. And then you have to also stand up. But we also should build up a culture within the plant that we accept that somebody is falling down. I would say, especially in some traditional German companies, you know, it's better to be slow and to be accurate, to think might be 1 or 2 additional times over that. We call it sometimes it's over-engineered because we spend too much time. I think we have to go in another way. You know, we have to be inspired. We have to take the energy and go forward and try something. And if we fall down, we do not have to say to him, I know it at the beginning. We have to tell him, come up, stand up, we go forward, and we learn out of it. So that's what I like as well, send you as a message. And last but not least, that's also my philosophy today. During the time I heard a lot of things. I believe these great things, I'm not able to collect everything at once. We have to work together and to find solutions for the problems together, not by yourself. And therefore, you are also welcome to cooperate and collaborate. Many thanks.